Hi, this video we're going to look at another example of moment about a point in 3D. And so here there's a bent tube. So there's a bent tube. It's attached to the wall with brackets showing. So DC and BC. So BC is a horizontal line and DC is a vertical line. Find the moment vector of the component of a force. This force here 820 pound and creates about point B, C, and D. So you're basically going to try to calculate three things. So first thing, they want you to calculate this force rotating about point B. Then also, we need to find this force rotating about point C and force rotating about D. So those are the three things we are solving. Once we got it for each one of them, you know, because it's a vector, right? It's IJK. And so we're going to basically get our MX. So you basically get our, this is basically your MX, this is MY, and this is our MZ. So you can fill this particular spots here, right? And then here basically is magnitude of that. So you figure out this. So for every single row, it's different moment. Okay, so how do we solve it? Here, let's go ahead and look at the first one. Moment of this force rotating about B. Okay. Well, this force, first of all, it's going from A to this point, and there's no particular point, but they give us this coordinate difference, so that's what we're going to use. So first step, we're going to figure out this force force along a line, and it's going to be this force magnitude without a hat, then times this position vector divided by its distance or magnitude. Basically it's unit vector. So how are we going to solve it? So this magnitude is 820, and here we're just going to use get the position vector right away. Position vector is from A to here, so that point is going to be our final point, and so it's final point minus the initial point, XYZ coordinate difference. And here they already gave us the coordinate. This is the X. So X coordinate, the difference is going to be right here, this dimension, so it's BI. And how about our Y direction? Y direction is going to be right here, so it's going to be A, right? And you look at it, you know, this point is at smaller value of Y compared to A because it's, you know, dash point is there. So this is going to be negative A. Okay, negative A for J. Then let's look at the K term, which is Z direction. And this point is certainly lower than A, so it's going to be negative. How much lower? It's going to be our C. So CK. So knowing all that, we can go ahead and calculate the distance. Therefore, we have this as our lambda. Then you can put your values in there. You got your I term and J term and K term, right, for this force. Okay, then the next step we will be solving is position vector. So this for this force rotating about B, we can write it right here. It's R cross F, and this R again have many possibilities. It's rotating from B, so it starts with B. Touch any point on this force, and looks like there's only one choice here for me because I can touch any other points showing here, but I really don't know the coordinate of those points, so I'm gonna go from B to A. That will be my easiest choice. BA cross F. So in that situation, I just need to find our BA, position vector BA. Like I said, BA is horizontal, okay? It's parallel to the ground. So if that's a situation, and we can go ahead just using the coordinate difference because BA is a position vector. So let's think about x direction. X direction, they're going to share the same x coordinate, which is right here, right? In that situation, it's basically equal to 0. So 0i. Now let's look at j. J, so b to a, so it's a minus b, okay? In terms of j, which is y direction, and how much away between them? It's d right there. So it's d, j, and it's positive because it's a minus b. Now let's look at k. B and A, it's at the same height, okay? If it's at the same height, then they won't have any k difference either. Knowing that, that's going to be our BA, okay? So it's 0, okay. So knowing that, you can go ahead and solve very last step. This F rotating about B, it's going to be your BA, which you know, cross F here. Then you will have your answers. Then, like we have speculated here, so that'll be your MX goes here, MY goes to that one, MZ going to that one, the magnitude going to that one, okay? So that's for that. If we were to do moment of this force rotating about C here, we're going to use position vector, R cross F, and our R here is going to be from C to any point on this force. Again, we're going to do C to A. So it's a CA cross F. All right. So here I'm going to just look at the CA. Position vector CA. CA, their x coordinate. So it's A minus C, right? Final minus initial. A is ahead of C, so it's gonna be negative. It's gonna be positive, right? A, since it's A minus C, because C is actually negative C, negative x, and so 0 minus negative G, that's gonna be G. So it's GI. Again, it's A minus C. A is ahead of C in terms of x direction. Now, the I term, that's our I term. How about Y? Again, it is C minus A. C is behind A in terms of Y. Then we're going to minus. How much? What's the difference in terms of Y? The Y coordinate is basically right there, your D, J. Okay? Then the last one is K. They are having the same height, okay? So in that situation, it's 0K, right? Okay, so knowing that, you can go ahead using the same F you calculate here to solve that problem. Now we're going to looking at potentially this force rotating about D and our R cross F. Knowing that it's going to be from D, rotational point, I'm going to erase all that. It's going to be from D to this point A. So it's DA cross F. Now we just need to figure out DA, right? What's our DA? DA is going to be A minus D. Again, A minus D in terms of X. A is ahead of X. How much ahead? That G. So it's GI. Now let's look at Y. A minus D. A is ahead of D. And how much ahead? This D right there. So it's A minus D. So it's plus D. J. Oh, now I'm just looking at this. I might have made a mistake in terms of CA here. For the J term, CA is going to be A minus C, right? For the J term, CA, so it's A minus C. A is actually ahead of C in terms of Y direction. How much ahead? D. So this is going to be equal to positive there. Okay. Just like what we have over here. Now let's look at the K term. So dA, so it's A minus D. A minus D, A is above D, so it's going to be positive value. How much above? A is, let's see how much above. Okay, A is the same level as C, and C is above D, H level. So A minus C, A is above D. How much? H. So it's going to be plus H. Okay. All right. So there's a lot going on here. Just make sure the signs, everything is correct, positive and negative. So once you have that, and you can again use what we have over here for DA, put it in, and use what we have for F, put it in, you will find a moment about force rotating about D. Then that will help you solve those three values there. All right, that's all I have for this one, and hopefully you got this right. And your web works. I'll see you next time. Bye.